Good afternoon, class. This is Mr. Martinez for 425. We're going to be looking at chapter 8.1. I know I didn't review it over class. I felt that it was something that you should know how to do. That's basically the whole section that reviews everything that you've done from chapters 1 through chapter 7. So it's going to be talking about solving linear equations, formulas, and linear inequalities. Still the applications, being able to address all of them. So the objectives that we are going to be having for this particular section is using the properties that we have. Remember, combined like terms, distributive property, isolating the variable, and all that fun stuff that you learned the first course of this one, which was 410, I believe. So what we want to be able to look at is use the properties of inequality to solve linear equations. Remember what equations are. Equations are the ones that actually have the equal sign to it, and it looks something like this, linear, right? You also may have inequalities that contain greater than, less than, greater than or equal to, or less than or equal to. So all of these we're going to be able to talk with in this one particular section. Again, you should know how to do the math behind it. We'll focus on some good problems that will help you understand the entire section that we have here. Okay? So we have different types of equations that we can have. This is called the two-step equation because you have to use two properties to be able to isolate A. This can be considered a one-step equation by simply multiplying both sides by the reciprocal of 3 over 7, so that will be multiplied to both sides to be able to isolate y. And then what we have next is a multi-step equation where you have variables on both sides. As you can see, here's the left-hand side, here's the right-hand side, and you want to be able to convert this multi-step equation into a two-step equation so that then you can go ahead and try to solve it. So these are the type of problems that I'm going to just be looking at really quick to help you out with this section. Here are 5 steps that we want to be able to look at, and I'm going to go ahead and analyze each of these steps. I do hope that you do follow these steps because it will help you, especially when it comes down to quizzes and tests. The more detail you are with your work, the better this is going to be. So let's go ahead and let's look at this really quick. The first one talks about having to clear an equation by two things. When we say, and we use the word clear, we're looking at these multipliers that are in front of each of the parentheses, okay? So the quantities that you have right here. So x plus 5 is one quantity. So what it's asking you to do is to be able to find the lowest common divisor of 2 and 4. In this case, is going to be 4. How do I know that? Because 2 could be seen as 2, 4, and then 6, and then 8. 2 could go into all of these, and the same thing with 4. 4 times 1, 4 times 2, 4 times 2 will be 8, and then 12, and then 16. And what we notice about these two, that the lowest one that both of these two have that are in common is going to be this 4. So the LCD between these two is going to be 4. And that's what I want to do. I want to be able to multiply everything that we have on both sides, not just one, by this 4. So 4 is going to be then multiplied to this 1/2, and then x plus 5 will come along for the ride, and this 4 will also be multiplied into 1/4, and then you have x minus 4 that's going to come along for the ride. When you do that, what ends up happening is that you basically are multiplying these two that you see right here, while you have the quantities of x plus 5 and the quantity of x minus 4 just come along for the ride. Remember, what we're trying to do here is we're trying to clear this fraction that we have in front, because we hate using fractions, and if we can simplify our lives, why not do that? So this becomes 4 cross, simplify if you wanted to. If you don't remember how to do that, you could go 4 times 1, which is 4. 4 divided by 2 will be 2. Now I have a whole number, and that whole number can now be multiplied into the quantity of x plus 5. The same thing with this one here. In this case, will be just 1, and then you have x minus 4. So what you've done now is you've cleared this fractions that you started off with into whole numbers, which makes your life 10 times easier. The same thing when you have decimals. When you have decimals here, so you have 6.1 and then 2.5, what you want to do is you want to be able to move that decimal over so that you can play with whole numbers. The way that you do that is you multiply everything by 10. Okay? And what I mean by multiply everything by 10, I mean that you multiply the 6.1 by 10, and then the x plus 3 will just come along for the ride. And then 10 times 2.5, and that will be 2.5. X minus 2 will just come along for the ride. When you do that, it actually moves the decimal place 1, so you'll end up with 61 times the quantity of x plus 3, and then you have 25 times the quantity of x minus 2. Okay? So these are two basic examples that help you understand what I mean by the word clear, the equation of fractions and decimals. Let's go back and let's look at number 2. So number 2 says simplify each side of the equation. Sometimes when you have this, the given equations, you're giving a distributive property here and then combine like terms. So this is the distributive property that we have to do, and this is combine like terms. What we want to do is simplify, make our lives a lot easier. That way we can go ahead and solve it. So we're just going to actually multiply this 3 into the given quantity of x minus 3. So we'll end up with 3x, and then we have minus 9 that is equal to, and we combine things that are alike. For example, these two have variables, so this will become 10x and then plus 6. Now what you've done is you simplify both sides, and now you can start moving things around, which will make it easier for us to be able to isolate the variable x. Let's look at number 3. It says isolate the variable terms on one side. What that means is basically go ahead and put all the variables to one side and then all the numbers to one side to make it easier. So isolate, right? Get it by itself. That's what it's asking you to do. So you get to use the subtraction property of equality here to be able to move this 3 that does not belong on the left hand side, and you'll end up with 5x that is equal to 10. Now what you've done is you use the property of addition to be able to move, or sometimes you'll use the property of subtraction, just like we did this one here, to be able to move to the other side. So that's the first one that when we say try to isolate the variable. First, move the numbers that are next to the variable that you have, so that you can start, then using the division property. And that's the one that we're going to next. The division one says that now that you have it into a one-step equation, we use either the multiplication property or the division property. So this is the last example. What we're going to use is we're going to use a division property of equality to be able to divide both sides by 5, and we end up with x is equal to 2, which is what we wanted. That's how you isolate when you have multiplication. You always do the opposite, which will be division. And if I see multiplication of, let's say for example, 2 tens, we could do the reciprocal just like I told you before, which will be 10 over 2 times x, right? 10 over 2 times 2 over 10 times x. And then whatever you do to one, so you do to the other side, which will be times 10 over 2. Or in my case, this is the way I like to teach this because it's just easier to remember. Now I get to multiply the 10 to the other side, so I end up with 2x is equal to 50. Then I get to divide both sides by 2, and I get that x is equal to 25. Either way, doesn't matter. The objective was to isolate the variable, and that's what you did. Let's go ahead and let's look at the last one that we have here. Just like always in math, we want to make sure that we do everything correct. So what we want to do is we want to be able to check to make sure that what we did is correct. So here's exactly what we have. We know that x turned out to be 2 here. I just solved it. It was the last example. What I want to do now is I want to be able to take this information that I know about x and then substitute it into the original equation just to make sure that the left-hand side is then equal to the right-hand side. And if this is true, I'll put a little check mark because that means that I've done it correct. So I have 5 times 2, I'll put that in parentheses, plus 3 is equal to 13. So I get 10 plus 3 is equal to 13. So 13 is equal to 13, which means I just checked my result to make sure that when I solve for x, it was correct. So we're going to take all this information, these 5 steps, and we're going to be able to solve a multi-step equation. That's what we're going to do next. So when you look at this one here, it says solve the following equation, right? There's 2 things that are happening. We have the left-hand side and we have the right-hand side. On the left-hand side, just like the last example that I gave you, we're going to do the distributive property. Then the right-hand side, we're going to combine things that are alike. I already done that for you, and I believe that this is one of the examples that the book has as well. So I'm just going to skim through it really quick just so that you can see how it's done. I encourage you, please make sure that you go through the examples on the book prior to doing the homework so that you understand. Now, there's 3 things that we need to know about this section, just like I said. Number one is one solution. As you can see, this one here is set to say that x has exactly one solution, because as you go through it and you start solving by doing the distributive property, combine like terms on this side, isolating the variable by starting to move things through, making sure that all the x's are on one side, making sure that all the numbers are on one side or the other side, we start noticing that x actually does have one solution. If we continue and we look at when we substitute it in, just to make sure that we check, we know that it is true. If I were to substitute 3 into x, both sides, both of them will equal 15. So it works, okay? It works. And I encourage you again to please make sure that you do that. The other 2 solutions that we may have is when we have what is called the identity. When you go through the whole solution and something happens, okay? So far we've talked about number 1, when you have x is equal to a number, and this will work. Number 2, when you have that same number, let's say 5, and then you have 5 on the other side, that is called the identity. And then number 3 will be, like for example, 0 is equal to 5. This is not true, because 0 does not equal to 5. So there's 3 things or 3 possible solutions that you can have when it comes down to identifying, the solution. So that's what I'm going to go do to these 2 examples. I showed you one example already that has one solution. This next one here is basically A. And what we notice about A is that at the end, we see that the left-hand side and the right-hand side, they're the same. And what ended up happening prior to that was that x, as you can see here. Okay, so we notice that here we have the variable negative 2x and 2x, negative 2x and 2x, and they simplify to 0. Please don't use the word cancel. They simplify, okay? So they simplify to 0, and then we're left just with the number negative 2 on the left-hand side and negative 2 on the right-hand side. When that happens, we notice that both sides contain the same number. That is also the equation as an identity. So this is an identity. And we say that no matter what x I substitute into my equation, it will always make the left-hand side and the right-hand side be the same number, which means that we have all real solutions, or we have an infinite amount of solutions that are all the real numbers that we have. So that's the second possibility that we have. The third possibility that we can have is when we have the left-hand side, as you see here, the left-hand side that does not equal the right-hand side. So it does not. So we put a little, we cross out the equal sign. That's telling us that they do not equal to one another. That means that we have the empty set or the null set, which means that there is no solutions. This is not true. I cannot find a single x that when I substitute is going to make this 2 statements to be true. That's what that means. So again, we have 3. One solution, infinite amount of solutions, and then we have no solutions whatsoever, and that will be the empty set that we have. So now I'm going to look at page 611, number 89, and I'm going to just walk you through as to how you would do a problem like this. I think that this is a really good problem for a quiz. This is a really good problem for a test. It does put everything that we just talked about, in chapters 1 through 7, plus understanding whether we have one solution, infinite amount of solutions, or no solutions. Okay, so we're just going to have to work through this. And I'm going to go ahead and do that for you. Let me zoom out just a little bit here so I have a little more room. Okay, what I want to do here is if I start doing the distributive property here, it's going to mess me up with everything. So when I look at something like this, I want to make sure that I take care of this parentheses first. So I'm going to work inside out. Okay, so remember that. When you have double parentheses, you want to work inside out. Okay, so that's what I'm going to take care of first. That's the first thing that I'm going to do. Everything else is just going to come along for the right. So I'm going to have -4, then I have my brackets. Brackets are exactly like parentheses, which means that I'm going to multiply eventually, not now. Now there is no number here, but there is an actual implication that there is a 1 in front. But this 1 is attached to this negative, so it's a -1. And this is what I'm going to distribute into these two terms that we have here. So we have -3. A negative times a negative makes it a positive, so I have plus p. Close the brackets, and then everything else comes along for the right. Remember, we're working inside out to make it easier for us to understand what is happening here. Okay, I still have to combine like terms inside here before I start distributing this -4. So everything else is going to come along for the right one more time until I combine like terms. So distributive property, combine like terms, and here we go. So I have 2p minus 3, close my brackets, and now I could go ahead and start using the distributive property to get rid of the bracket and to get rid of this parentheses that you see here. So now I'm just going to go ahead and multiply these out. So I have -8p plus, right, 4 times 3 will give me 12. Remember, it's a negative times a negative. That's how I got that positive. And then I have 3 times 6, which is going to give me 18p. And then 3 times -2, which is going to give me -6. Okay, so what I've done so far is I simplified, then I use distributive property, then I combine like terms to be able to make sure that I can get rid of all parentheses and brackets to start solving this. Okay, so that's what I'm doing now. I'm going to start moving things around. I'm going to move all the variables to one side and all the numbers to the other side. I am a firm believer of having the variables always be positive. It's just easier to see it that way. So I'm going to use the addition property of equality to be able to move the 8p to the other side, which simplifies here, and I end up with 12 is equal to, and now I'm going to have 18 plus 8, which is going to give me 26, so I have 26p. -6 comes along for the ride, and now this is a two-step equation where I get to add 6 to both sides, and I end up with, not divide, add 6 to both sides. This simplifies, then I get 18 is equal to 26p, then I get to divide both sides by 26. Just going to rewrite it this time with p in the front. So p is equal to 18 over 26, and then I can simplify this by dividing both top and bottom by 2, and I get that p turns out to be 9 over 13. And we're going to keep it as a fraction. We're not going to put it as a decimal. So, okay, like I said, so this is a really good problem for a quiz, a really good problem for a test, even for the final. I feel that this one hits on everything that we need to be able to understand what it is that we are doing in this section. Okay, the next video is going to be about 8.2.